Right, so I've been doing some work on this. I've resoldered a bunch of joints in the back of the analog board, which weren't really soldered very well on the top of the board, that kind of stuff. Let's turn some of these lights off. Maybe that'll help us a little bit. It's going to get dim. There you go, you can see it. Okay, so here's some capacitors to try. That's an inductor. And I've already done this, so I'm going to show you anyway. I can't zero it, that's still an issue. If I put that big capacitor on here, let's say 15,000 microfarad. 15.4. Next one is a 2,200 microfarad. Yeah, just 2,090. That works. Next one here. What's this one? This is a 680. Yep. 670. Close enough. Now this has got multiple ranges in. Each one of these capacitors I'm changing is in a different range of the meter, which is why I'm doing this. And you'll see why in a minute. 0.342. And this is a 33 microfarad. 33. What annunciator did I have over here? Middle annunciator and 0.34. So it's not actually right. So this is a 33 microfarad, and it says much less than that, saying 0.3. That's interesting. Next one here. This is a 2.2 microfarad. It's measuring in picofarad, not microfarad. So this one here is weird. Let's go back to this one. It should be 33, so really that decimal should be over here. So I'm not quite sure what's going on there. Doesn't seem right. And this one here is a 1 microfarad. So now we've got these two here, which are different. This is 0.68 microfarad. Obviously it's a film cap instead. Doesn't work. And then this one here, another electrolytic. This is a 0.47. Again, these are different ranges, alright? Right, not working anyway. Doesn't matter why it's on there or not. Still doesn't work. No difference. So basically it seems like anything below about 1 microfarad, it doesn't see. Which is why I can't null them out, because it's giving this error, it doesn't matter what happens. So these are clues, because it's got multiple ranges. Now I managed to find the circuit description for this thing online. It's actually on the Sencore group. Someone had uploaded to the Sencore Google groups, and so I grabbed it from there. I haven't seen it anywhere else. It's the only place I've seen it, and that actually discusses the actual ranges and stuff like that. So it tells you what the ranges are, what the limits are, and that kind of thing, and how some of the functionality of the circuitry is. That has told me a bit about how this thing works, and that's how I know about the ranges and what limits to put in. So that's range A, B, C, D is 40, E, F, G, H onwards, and that's what it's described as range A through to something else. I think this goes to J. You've got some weirdness with this range here. I say these ones below 1 microfarad don't work. So I think it's like 0.9 microfarad. Yeah, I think it's 9 to 90, and that's 90 to 900, that one there. Yeah. Some things to look into. It's giving some clues about where to look. And that's what we get in 680 microfarad basically, right? So this one's right. But if you scale below this one, it's wrong, because 33, 2.2 and 1 are all giving a order of magnitude, or 2 orders of magnitude below what they should be. So that decimal place should be over by 2 places, as it should be in these other ones. So this is out by 2 orders of magnitude. Now that could be that same fault across all the ranges, because if these are also out by 2 orders of magnitude from where they're supposed to be, you won't be able to read them. Could be one fault for all of those. Great. Another thing I want to show is the leakage. This works on the low range, not on the high range, which kind of doesn't make sense, because it uses the high range one. It's like 2 resistors in series, and it bypasses one of them to do the high range, and the low range it uses them both in series. So the low range works, high range doesn't, unless it's a really small value cap or something. So that's a bit weird too. Okay, well, clues to work on. So I'm just going to track down the ranging circuitry first, because we've got 2 problems with this, the leakage and the ranging. The ranging is something that's probably going to be a bit easier to diagnose in some ways. We've got some clues. We know that the higher levels are indeed working correctly, but the lower levels are not. I've hooked up my scope. I'm probing on IC6, which is the 4077, which is the thing which does the range switching. That gets a bunch of clock pulses which tells it which range to go into, and then it then outputs signals depending on which pin it is, because it's a decade counter. So one pin of the 10 will be high, the rest will be low, and that's when it sets the ranges. Now we know that it's out by maybe 2 ranges. It's like 2 orders of magnitude out, so I think it's 2 ranges out on the lower levels. Now because this is based on a clocking signal, we can check that. I've already been doing some testing, so I can show you that as well. I'm going to probe on pin 14 of IC6, and that is the clock pin. Then the pulses on pin 14 will count which range it's in. So one pulse is range 1 or range A, and 2 pulses is range B, 3 pulses is range C, and so on. Okay, and I'm going to show you that on a scope. That pin there is what I'm going to probe on. Just bend out of the way so you can see the chip. Right, pin 14, and I'm going to show you the scope. So I've currently got the biggest capacitor attached, which is range 1 or range A. And I probe on the pin. This is with the button out, so you see a bunch of pulses. That's normal. When it doesn't have a range selected, because you're not trying to choose a value, that's what it does. It just constantly pulses. Let's push the value button in. I've got quite a slow acquisition time because I'm trying to catch long pulses, but that's 1 pulse. Okay, 1 pulse. That's range A. Let's change the capacitor. Let's go to the next smallest one, which should put it into range B. Probe on pin 14. Push the button. Now you're getting a couple of pulses, although it's a bit hard to see. Right? It's not necessarily clear, but it's actually 2 pulses. It gets clearer as it goes along. Next one should be range C, and you've got 3 pulses. You see there's a group of 3 with a, the mark space ratio. You've got a space there between them, so you've got 3 pulses there. That's range C. Now I've got another one here. This is a 220 microfarad, so I think this one's still range C. Remember rightly? Yeah, I think this one's still range C. So there should still be 3 pulses, but it'll be different pulses because the capacity value is different. I noticed that before. It's now a bit more distinct. The smaller the capacitor, the more obvious the pulses are. Right, so it's still range C. Set it as a 220. Now I'm going to do a 82 microfarad, which should be range D. So we should see 4 pulses. We're not seeing 4 pulses. We're seeing 6 pulses. That's 2 pulses too many. 2 pulses means 2 ranges wrong. That ties in as well with the issue we're seeing with it being out by 2 orders of magnitude. Let's go to one we showed before. This is I'm trying to read it, 33 microfarad. So this should also be in range D. Do it again. And we're still seeing 6 pulses. So that ties in. So if I go right down to the 1 microfarad, this should still be range D. Might actually just increase the time base slightly, just to make it a bit quicker. So this should still be range D. There we go, still got 6 pulses. There's a bit of jitter and stuff on here too, but that almost looks like 7 pulses actually. But that's 1 microfarad, so it's getting close to the limit of that one. So if I then go down to 0.68, well, it should be range E, should be 5 pulses on this one. And now we're getting, how many pulses is that? 4, 8, 9, 10 pulses, something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 1 Yeah, so the pulses going into that chip, which set the range, are wrong. There's a big clue. So that clock pulse is coming from IC23 on pin 13. Now this is currently without the button pushed in to check value, and we're getting 6 pulses, maybe 7, sometimes 8. It's varying a little bit, which is quite interesting. And this is obviously without the button pushed in. Yeah, 7 there right now. Sometimes it goes to 8, like it's now it's 8. So there's something a bit weird going on here. And if I push the button in, suddenly we've got more pulses. When it's doing a test, it adds more pulses on. So right now, 6 to 7 pulses is probably right for this capacitor. I think it's supposed to be 6. I have to go and double check that. But like I said, when you push the button, it increases it. So it's a bit weird. So I'll switch back to auto mode triggering. Let's check pin 11, which is the clock pin for this chip, to see what's happening there. There's pin 11. They're the pulses. That's currently 7 pulses. Push the button, it's jumped up. So that's the input to that chip. So that chip itself has been told with extra pulses that, hey, it's wrong. So we need to backtrack a bit further from that. IC18 looks to be the source. It does. So IC18, pins 12 and 13, where we need to look at next. I've just got to find that chip. So right now I'm probing on pin 12, and as you can see it's a negative going signal, and it's not actually going right down to 0 volts, it's like 2.4 volts. Anyway, if I push the value button, we get more pulses. So that's on pin 12. So pin 12 is shifting. Let's do pin 13. So those levels are going much lower. So straight away it makes me wonder, because that's going to 0 volts. And push the button, and we're getting more pulses as well though. But it seems more erratic on that one. But what makes me suspicious is that pin 12, that low level is not pulling right down. I would expect that to go lower than that, unless somebody's trying to pull it up. That's interesting. So that signal that goes into pin 12 of IC23 comes from pin 12 of IC22. And there's a signal level there. It's actually got a resistor in between the two, so that could explain that. I don't know why I got a 100k resistor in between them. It's also reduced loading or something, I'm not quite sure. It's a bit weird. But that's why that level's different, because they don't actually have a resistor in there. It's a bit weird. Usually you want logic signals, you want to actually have them controlled properly. So that's coming from that IC as well. I need to backtrack further from that, which is on pin 11 is the clock. There's the clock that's going into it. Push the button. We've got extra clock pulses, so it's coming from the clock line. Okay, that's coming from IC18 pin 4. You go and find that one. So I've gone back to found the IC. So I'm now on pin number 1, 2, 4, 5. It's pin 5 of IC18, which is one of the inputs. Push the button. Got extra pulses. Okay, let's go to pin 6, which is another input. Looks very similar, strangely. And again, push the button, extra pulses. It's on both of those inputs. Now one of those comes from IC20, which appears to be an op amp. So LM311. So I might need to look at that, but I think that's probably going to be fine. This just keeps on getting more and more curious. Okay, so I'm looking at IC20. This is pin 2, which is just high. It's got those pulses like that, which looks fine. If I do pin 3, this is those pulses we're expecting to see, and when we push the button we're getting the extra pulses. So that pin 3 is the same on 20 and 21. They share it, the same signals, which is why we're seeing on both pins of that other device, IC18. So that signal on both of those pins appears to come from junction 7, which I now need to go and track. So interesting, that pin 7 junction comes from the TO084, which is on the analog board on the other side, which is just a buffer. So I'm just trying to figure out how that's getting pulses, because that's actually tied to the input capacitance. So it's getting pulses there. It is switching a couple of transistors by the looks of it, so I'm going to go and probe those, but that's actually, I can probably probe them from this side. So I want junction 13 and 14 and maybe 11. 11, 13 and 14. I'm going to find those ones on this board because those are what control that section. Well, I have to say this is frustrating. I just tracked back where 11, 13 and 14 come from. 11 is actually linked to 5. 11 and 5 are basically the same signal, and we've already determined where 5 is coming from. So that explains the 11. 13 and 14 are the outputs of some devices which come from the 4017. So those are, I've lost them. So those come from IC9, which is fed from the 4017. So it's like a big loop. So now I'm kind of stuck. I'm thinking, okay, well, we've got these extra pulses. Where are they coming from? Because it seems to be like a loop. That is so annoying. If I can find IC9, I'll probe that. I wish it was a bit easier to see on the board. And I found it within 1 second of closing the camera off. It's right there. IC9. So we want pin number 1, just there. And we're currently getting long pulses. Yeah, big pulses with a button pushed in. With a little glitchy pulse to start with, which is interesting. But when it's off, we're getting about 0.7 volts. I think it should be fine. Pin 13 is the other one, so that'll be that pin there. And that's a high state of 7 volts. The button pushed in, we're getting low pulses with a glitch in, which I'm going to show you. So I'll probe those again. Pin number 1. So there's that partially high state. Well, it's a low state, so it's, what's that, 1 volt. And that's where the button pushed in. And we've also got one little glitchy pulse in there as well before the big pulse. And that could be related. And pin 13, just there. That's fully high. Then I push a button in. We're getting that with a glitchy pulse in the middle of it. Come full circle. Right back to the beginning where we started from. And I don't know where that pulse is coming from, really. Generating itself, I might need to look at the inputs more in those devices because there must be a input there which is not directly from that. I need to look at that in more detail. So one of the things in the manual says about troubleshooting this thing is to actually lock ranges on it. So you can actually force it to go into a certain range and disable auto ranging. So you can then diagnose if there's a particular issue with a particular range. So that's what I'm doing right now. So I've got these easy hooks on here, hooked up onto the 4017, which is the device which actually controls the ranges. So basically I'm shunting the pin 15 reset pin to VCC, so it's, in this case it's 7 volts. I've got pin 3 grounded, because that needs to shut off the range A output, and then I've got currently pin 7 hooked up to the VCC as well. And I've got another easy hook behind here which is going to the ground pin for this grounding here. So this is forcing it into a range which uses pin 7, which is D. That's range D. So I'm forcing into D right now, so let's go into this. And I'll just show you this. So, alright, so pin 15 7 volts, as you can see, so that's in reset. Pin 7 is also 7 volts, so it's trying to force on range D. And pin 3 is 0 volts, so it's disabling range A. Okay, so if I push this button here, that should be in range D. Right, so I'll just confirm by pushing the range D there, nothing there. I've already checked the other pins to make sure there's nothing happening. Check the reset just to make sure. Reset is still high, so that is in range D. So what capacitance should we be able to see with that? So range D should be able to work for between 9 and 90 microfarads. Right here I have a 33 microfarad capacitor, which I can try and get hooked on so it actually stays on there, it'd be nice. So I push this, we should see 33 microfarad on the display. And we see nothing. Range D appears not to be working. We'll keep looking, see what other problems we might find. So now I've hooked up to pin 10. Let's verify that. Pin 10 is high. So that is range E. So that's 0.9 to 9 microfarad. I've got a 2.2 microfarad hooked up. Let's see if it actually does it. It does not. Keep looking. So I've now hooked up to pin 1, which is range F. So that's 0.09 to 0.9 microfarad. I've got a 0.68 capacitor here hooked up. Nothing happening there either. So now I'm hooked up to range G, which is pin number 5. And that's supposed to be for 9,000 to 90,000 picofarad, so 9 nanofarad to 90 nanofarad. I've got a 68 nanofarad capacitor right here. Do you see if this does anything? Nope. Nothing. So the next one is range H, which is supposed to be 900 picofarad to 9,000 picofarad, 0.1 nanofarad up to 9 nanofarad, 6.8 nanofarad here. Let's see if this one works. No, nothing. But you can see we've got extra digit. So the actual range selection is working. I now hooked up pin 9, which is range I. And this is for 90 to 900 picofarad. This is a 680 picofarad capacitor. Let's see if this one does anything. Nope. Seeing a trend. Now on the final range, range J, which is on pin 11. This is a 9 to 90 picofarad range. I've got a 68 picofarad capacitor connected, and we have something. We're getting minus 2.4. So that's wrong. I don't think we can do a zero on this. No, it's doing nothing, and that's just like having no capacitor connected whatsoever. I'll take it off completely, so there's nothing connected. Do it again, it's exactly the same. That's basically range D downwards which aren't working. Interesting. And just to prove the system is actually working, I've put it back onto range C, which I already previously tested before I start recording. I've hooked up a 220 microfarad capacitor because there's a 90 to 900 microfarad range. And I push the button and we're seeing 210 microfarad. So this actual process is working itself, but it means that range D downwards doesn't work. So that's very interesting. And that could narrow it down quite a bit, because if it's just one range that didn't work, then it could be causing issues with auto ranging. But it's not. It's a whole block of ranges, which means it could well be some kind of signal which is shared between all those ranges, and it's scaled or something, and then from the one point it just dies and that's the end of it. So that gives me some clues to work from. Not much in the way of clues, but something. So let's just look a bit deeper. I've gone back onto range D, which isn't working properly. Let's hook up a capacitor, which should be 33 microfarad, and push this, and it should do nothing. If it's still broken, it is. So IC number 9 over here. This is the next step in the chain. After this, it's a NOR gate, 4-input NOR gate. So what I need to do is check the inputs and the output of that gate to make sure they're all doing what they're supposed to do. So I think we should only have one input. So pin 9. I think pushing that is going to matter, but we'll do it anyway. Low, low, low. Should have one high one. There we go. 6.3, and the output should be low. It is. Okay, so that side of that gate is working correctly. Okay, let's check the other side, which are pins what? 1, 2, 3, 4, and 5. So pin 1 is the output. That is high, which means all the inputs should be low. Low, 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 low. That seems correct. That appears to be working correctly. Let's just push a button just in case anything changes. Yep, no, that's fine. And so pin 13 of this one here was the output. So that gate looks like it's behaving. It's not that gate. Let's go deeper. So now let's check the next thing, which is IC8, which is an AND gate. Pins 1, 2 and 3, which is over here. Pin 1, high. Pin 2, low. Pin 3, high. That's correct. So I'll just check TR4, which is the next thing in that chain, which is a 2N3904 NPN transistor. I checked that the base is high like it should be. The collector goes to a 7V rail through resistor, and then the emitter goes down to ground. So when it's turned on, it pulls the output down to ground, which then controls the line. And those are correct, those levels are correct. From what I can see, this particular path so far doesn't have an issue. It might be the other path which all the stuff goes to. So next thing I'm going to quick check for, which you won't be able to see initially. I might show you on a scope, I'm not sure. I'm checking for the frequencies coming out of this here. This is the IC16. I need to look at pin 9. Now, with it forced into range D, that should be generating a 10 kHz clock at pin 9 of this IC. So let's probe onto here, pin 9, and I'm definitely seeing something there. 10 kHz, indeed I'm seeing it. I push the test button, 10.0031 kHz, so that's perfectly fine. Damn. That's one less thing to check, I suppose, but the clock there is right. Pin 9 is right there, and there's the frequency we're getting there. Say 10 kHz pulses. That's what it looks like, with a lot of AC ripple because my grounding's not great. So what I've decided to do now is probe, a bit like a logic probe basically. I'm not actually using a logic probe, I'm just using analog channels, but probing on the outputs of these resistors here, which go after the various stages, from the IC6, which is the one which sets sort of ranges up. I'm not really getting anywhere with it. I haven't found anything which is actually like something which is obviously wrong. It just doesn't work right. So I'm just trying to pin down what's going on. And I'm kind of thinking, the ranging seems to be one of the keys to this. So what I've got right now is I've got 4 probes hooked up onto this IC here. This is a ground reference, that one there. This one's not been used. Onto the IC, and I'm checking range A, B, C and D. 4 ranges at once. So what should happen, it should open at the A range first, then check the B range, then check the C range, then check the D range, right? And it should keep going on through to J. It should do them in sequence. With no capacitor on there, you should see it trying to go through. Now don't forget, I've still got the zero issue. Can't zero properly. Still says -2. So far I'm going to figure out what's going on there, but it could well be related to this problem. I'm going to show you the scope, and we can see what waveforms are getting out with no capacitor on. Then I'm going to go through and test with different size capacitors. One that should be within each range of the unit, and should be able to see it going through each range and stopping on that range to prove that range is then functional. And I can tell you whether or not it's functioning or not. So I've got this set up for normal triggering, so it will just capture and then hold it on screen so I do another capture. So if I just push the value button right now, that's what we're getting with no capacitor on it. Okay, so you see it stepping down. When it's high, look at this one here, okay, with that one high, that is then active. So with no capacitor on, it should get range A high, then it should turn off. Range B should go high, that should turn off. Range C should go high, should turn off. Range D should go high. Wait a minute, there's no high there. Okay, let's shift these over by 1, so that'll become channel, B, C, D and then E. We'll shift them all over by 1 and see what happens. Okay, they're now shifted over by 1, so let's reacquire. So now we should see, look, there we go. So that's B, C, no D, but there's E. Move them over again. So now what will happen is this will be C, D, E and F. Push the button. Do you see a pattern here? Output D has got nothing on it. As is a counter, output D should have something there, because it's a counter, it should go from one to the next. Now I've just moved the very last probe over by 1, because obviously I go the whole lot over, but then you might get a trigger source because D's not working. So it should be G on the bottom now. Should see it shift over. There we go. So G is working. Okay, let's keep going. What's the next one I'll look for? So I've moved that last probe over one more time, so it's now on H. So you should see the green line shift over by 1. Pushing the button. Green line has disappeared. Interesting. Let's just adjust the probe in case it's not got a good connection. No. Okay. let's do the next one over, which should be I. Try it again. I is there. D and H are missing. Let's try the last one, which should be J. The green line should move over. It has. Alright, so we've got 2 outputs missing from the counter. The counter's dead. That's what's wrong, I think. We'll replace that counter. Started desoldering this IC. I've put some solder on the top side to help freshen that up. I've also just put some solder on the bottom side. Nothing too exciting so far. Now it's time to desolder it. Hopefully it'll come out okay. There's always a risk of damaging traces with these older boards, so I'm hoping it's alright, we'll see. Right. Question is that IC free now? I'm going to check the pins individually, because the main thing I'm worried about is ripping a trace off the top side of the board. So let me just inspect this. Hopefully you can see what I'm doing. I can barely see what I'm doing, so... Right, does the pin move? Yes. 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 Yes, 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 yep, not sure, barely. That one feels like it's still attached on the top, so does that one, so does that one, or does it just move? I think it'll just come off here. Okay, there's a couple here which I'm not sure about. That one there, yeah, I think this one here is still attached. So let's just put some more solder on that and try desoldering that one again. Could be a ground plane or something there, I'm not sure. Let's have a look. Yep, there's definitely some movements there now. Right, see if I can pop the chip out. The chip there. Yeah, it's looking fine actually. Great. That's out. And no damage. So pin 1 is that corner, which is marked on the PCB anyway with a semicircle there. Got to clean these pads up. You see it's actually not actually soldered on the top side almost at all. There's very little solder on the top side at all. Let's turn it off. I'm going to clean these up, bit of fiberglass brush just to clean those up so that will solder through, and I'm going to put an IC socket in there. So I've cleaned those holes up, I've got myself an IC socket here. I actually might just give this a bit of a brush with the fiberglass as well, just to make sure these are nice and fresh. I've had these sockets sitting around for a while. I do actually have some nicer sockets, some roll pin ones. It's just a counter, it doesn't really need high precision sockets, it just needs to make some kind of connection. So I'm not going to use those for that. In fact, think about it, I might even do the same thing to the IC. I've had this IC sitting around for a while as well. I was actually just went to go and check, and for the start my stock of these ICs is quite low. I only had 2 of them left, and then I went, I better go and buy some more. And turns out this particular one's not made anymore. So like, ooh, that's not good. So it's a standard IC, I mean, it used to be really common. Seems that people don't use them anymore, so... Anyway, we'll pop the socket in there, I'm going to solder that socket in. Now also going to compare the old chip with the new one on the tester to see what they come out like. Positioned it, just tacked 4 corners in, just very roughly. They may or may not be adhering. So now I'm going to solder these in. Plenty of solder. Get the flow right through to the other side. I was really worried about this, I put a lot of extra flux on, but I'm not. I mean, most of the connections are on the bottom side anyway. There's a couple of pins which are on the top side. But but most of them on the bottom. And what I've done is already cleaned them up to make them better, so there's a good chance that they're fine anyway. Should be better than original, really. Now the temperature on this is actually quite high. Got my temperature set to 350 degrees C, which is probably really pushing it for this board, but I want to get the solder to flow through to the other side and help it to get through quickly without putting too much heat onto the board by having it on there for too long. There you go, all cleaned up. Looks as good as new, if not better. Perfect. I'll put this thing back together, and before I test it I'm going to get an IC tester out and actually test this IC that we pulled out of it to see what it comes out as. Right, so I've got my Retro Chip Tester Pro out. Let's see what this thinks of it. Here we go, Logic 7500, 4000 logic tests, and I want 417, 417. Okay, put the chip in there. So this is the brand new one. That passes just fine. Let's put the one which I pulled out of. Failed. Sure enough. Bad chip. Excellent. We actually found a problem. That's brilliant. I'm going to put the new chip in here and we'll try it out and see if anything's actually improved. How many problems are solved by fixing that chip? Right, moment of truth. Leads are open. Can I zero it now? That's no different. Okay. That doesn't mean anything's bad though. Let's get a capacitor which I know was failing before. This is a 33 microfarad. Still reading incorrectly. Still reading 0.3. So although that chip was bad, that apparently wasn't the only problem. Well, that's annoying. I was hopeful. Let's try this one. This one here is a 0.1 microfarad. Again, that's not working correctly. So we did find a problem, but I didn't solve it.